Hi, I'm Dr. Bill Carlizon, Principal Editor of NPP Digital Psychiatry and Neuroscience. Welcome to the DPN Deep Dive, our journal's AI-generated podcast that summarizes DPN articles in short, accessible episodes. Each episode is approved by the authors and designed to make listening easy and fun. Let's dive into this episode to explore the latest research in digital psychiatry and neuroscience.
If you or someone you know has gone through major depression, you know that recovery isn't always the end of the story. There's this constant concern about recurrence.
Exactly, the shadow that hangs over remission.
And just asking about symptoms often isn't enough. It doesn't really capture who might be at risk of slipping back. We really need better markers for that, that lingering vulnerability.
Well, that's what today's deep dive is all about. It's about integrating what's happening inside the brain with what's happening outside in the real world.
Specifically, how we express emotion in our day-to-day communication.
Yes, looking past the surface to find something more predictive.
That's a huge step forward. This research comes from an article titled EEG-based Brain Connectivity and Sentiment Analysis from Smartphone Social Communication, Insights into Remitted Major Depressive Disorder Among Adolescents.
It's a joint effort from teams at Columbia University and Northwestern University.
So let's get into the design. They had 144 adolescents participate, some who had recovered from depression and some healthy controls, and they started by collecting brain data.
Right, they used electroencephalography, or EEG, to look at resting state brain connectivity.
But here's the really unique part. Over 180 days, they also collected smartphone messages.
And this is key. It was collected passively. They gathered about 2.3 million messages without the teens having to do anything.
Wow. And from that, they analyzed the language.
They used sentiment analysis, basically quantifying how often these teens use positive versus negative emotion words in their everyday texting.
A fascinating combination. So before even looking at the future, what did those initial brain scans show? Was there a difference between the groups?
Oh, yeah, a clear one. The youth who had recovered from depression showed this core imbalance. In the slower brainwave frequencies, delta and theta, their brains were hyperconnected.
They're strong.
Too strong, right. But in the faster frequencies, alpha, beta, gamma, the ones you use for active thinking, they showed hypoconnectivity, weaker connections. It points to a kind of inefficiency in processing.
Okay, so there's this baseline imbalance. The real question is, did these patterns actually predict who was going to struggle over the next 6 months?
They did, and this is where it gets really insightful, because they found two distinct predictive patterns, not just one.
Two different markers.
Exactly.
Yeah.
The first one was all about predicting future symptoms, things like rumination.
The internal experience.
Right. They found the reduced alpha band connectivity between two brain areas, the mid-cingulate cortex and the precuneus, was linked to greater depressive symptoms 6 months later. And for you, the listener, those are the brain's hubs for self-referential thought, how you think about yourself.
So a weaker connection there is like a flag for internal risk. But what about the external side? The negative language in their texts, was that the same pattern?
That's the surprising part. No, it was a completely different neural signature.
Really?
For predicting negative emotional expression, they found that lower connectivity in the faster beta and gamma bands was the key, specifically between the precuneus and the middle temporal gyrus.
And that area is more about language.
It's critical for understanding word meaning and social context. So it seems the brain has one signature for internal struggle and a totally separate one for how that struggle gets expressed out in the world.
That distinction is it's huge. It suggests we could potentially identify vulnerability for internal rumination separately from vulnerability for, say, negative social engagement.
Now, we do have to ground this a bit. There are limitations. This was a 32-channel EEG, which has limited spatial resolution, and it was resting state data.
Meaning we don't know exactly what the brain was doing while they were texting?
Precisely. Still, the insight is incredibly powerful.
It really is. It leaves you with this final thought. If these brain and language markers hold up, how could future tech use this kind of integrated data to intervene before a relapse ever happens? It's a roadmap for truly preventative care.
Thanks for listening to the DPN Deep Dive. Until next time.